is the effect of temperature on the rate of a chemical reaction? Well, let's find out. We are going to react two chemical substances which are sodium thiosulfate and hydrochloric acid. On the board, we have a balanced chemical equation which represents the reaction. Sodium thiosulfate in aqueous form reacts with hydrochloric acid in aqueous form to produce sodium chloride in aqueous form, sulfur in solid form, sulfur dioxide in gas form, as well as water in liquid form. Over here, I have two flat bottom flasks. They each contain 50 cubic centimeters of the solution of sodium thiosulfate. This one is at room temperature. The other one has been heated to a temperature of about 65 degrees Celsius. I also have two test tubes which contain the same amount of the solution of hydrochloric acid, which is 15 cubic centimeters. Now, as you can see on the board, the sulfur which is produced is in solid form. It is actually a precipitate with a yellow color. We can use the formation of the precipitate to measure the rate of the chemical reaction. How do we go about working on that? Okay, as you can see over here, I have a piece of paper with a cross in the middle, a black cross in the middle. Let me put that piece of paper in front of this flask and place the flask on top of the cross on the piece of paper. From there, I'm simply going to take this solution of hydrochloric acid and quickly pour it into the flask, the flat bottom flask. As you can see, I also have a stopwatch. With this stopwatch, I'm just going to measure the time taken for the cross at the bottom of the flask to disappear. Let's observe and see what happens. The cross has disappeared. It took about 16,18 seconds. Now, with this experiment, the time it took the cross at the bottom of the flask to disappear is 16. Now, let's look at the one which was heated to a temperature of about 65 degrees Celsius. Okay, let me remove this one. Place it over there. Okay. And let me reset this. Okay, I'm quickly going to pour the solution of hydrochloric acid into the second flask, and let's observe and see what happens. That was quick. This one did not take a long time. It took about 2,84 seconds. We can safely conclude that an increase in temperature increases the rate of a chemical reaction. Bear in mind, in the first experiment, the cross at the bottom of the flat bottom flask took about 16. In the second experiment, the cross took about 2,84 seconds to disappear. As you can see, this time is a very short time. So we can simply conclude that an increase in temperature increases the rate of a chemical reaction. That is basically how temperature affects the rate of a chemical reaction. And we should be able to explain this by making use of the collision theory. According to the collision theory, when temperature increases, the kinetic energy of the particles of the reacting substances also increases. As a result, more effective collisions per unit time will occur, thus leading to an increase in the rate of chemical reaction. Thank you very much for your attention. For more useful information in the learning areas of mathematics and physical sciences, please subscribe to our YouTube channel at PP Maths and Science Lab. Thank you.